Hello everyone and welcome to our second part about this function study. So in the first video we found out the domain and the limits of this function, and now today we're going to focus on the first derivative. So I've written again here the function and we calculate the derivative of this function. Now when this is now a simple formula, when a function is a fraction like here, the derivative is this. Okay, so simply by applying that, we will find, let me write here. So if u is 6 plus 5x plus x squared, u is 5 plus 2x, and v is, and this is going to be the same, this derivative. Okay, so now let's just put in what we just calculated. Okay, divided by x plus 1 squared. Now, since this in every single of these factors, it's multiplied by exponential to x plus 1, we can divide once by exponential x plus 1, and we're left with 2x plus 5 minus x squared minus 5x minus 6 divided by exponential x plus 1, which is equal to minus x squared minus 3x minus 1 divided by exponential x plus 1. Okay, this is our first derivative. Now we want to know, when is this derivative 0? For this, we're going to use a very famous formula that you probably know, that is the delta formula. So here it's 5, and so x1 or x2, and we find out that x1 is minus 3 plus square root of 5 divided by 2, and x2 is minus 3 minus square root of 5 divided by 2. Let's just give an approximate value so we know what this corresponds to. So minus 3 plus 5 divided by 2. This is approximately equal to minus 0.38, and minus 3 minus square root of 5 divided by 2 is approximately equal to minus 2.61. Okay, just so we have a little idea. What we're going to do now is, the second question is find extremes. So we're going to do a variation table like this. We're going to have our first derivative of the function, and we're going to have the function. So what we want to do now is we put in the values we found here and this one. Why? What does that mean? At these two values, our first derivative is equal to 0. That's what we found out here, right? At these two values. Now we have to know if x here is minus infinity and if here is plus infinity. We have to know if x is here, will the result be positive or will it be negative? Okay, so in order to do that, let's just take, for the sake of this example, like minus 1. So if we put minus 1 in here, we get 1 minus plus 3, so 2 minus 1, which is equal to 1 divided by exponential, but exponential will always be positive. So if we find ourselves here, the result will be positive. And as such, all the other will be negative. Now, what does that mean? That means that, as we found out right here in our first part of the exercise about the limits, we found out that when x comes from minus infinity, the limit is plus infinity. So we know that the function comes from here, from plus infinity, and it is downward sloping. That's what we found out, thanks to the minus. It's downward sloping until a certain point, until this point right here. Okay, now I'm not going to do the calculus, but you just have to put in this value into the function and you will find out what this value equals to. In this case, it's minus 1.19. I already did that in advance. And from this point on, what we found out is it goes up again. So it goes up until a certain point. Now, if we do once again, you put this into the function, you found out that this is 2.28. And then it goes down again. And where? Let's come back to the first part that we did. We found out that when x goes to plus infinity, its limit is 0 plus. So it is 0 coming from above. So this is our limit. So what does that mean? This means that minus 1.19 is a minimum of this function, and 2.28 is a maximum of this function. So already, just to give you some idea, we know that it's going to be like this, and then that. It's going to be approximately like that, with this being minus 1.19, and this being 2.28, and this being it going to 0, approximately. In the next part, we're going to draw the exact graph, and you will see how to do it. Okay, so this is everything we had to do for our first derivative. In the next video, we will do the second derivative and find inflection points. Thanks for watching. Have a good day.